For lesson 8.7, we're going to look at solving systems of linear equations. Essential question is to find out what are some ways to solve systems of linear equations. So we're going to use a couple of different ways to find out a solution for a system of linear equation. So first we'll have to identify what is a system of linear equation. By definition, it's going to be two or more linear equations together as a set. So in our questions, you're going to have two different equations given to you, and you'll ask to solve each system of equation by graphing or by solving it for another variable. Let's start with our first example of the system of equation. We have y equals x minus 7 and y equals 4x plus 2. So first, I'm going to use the slope and intercept form to graph my two different graphs on the same plane. And then once I graph those two equations, I am going to find out the point that two are going to meet up. So I'm going to go ahead and graph it. The first one will have the y-intercept of -7, and then the second one will have the y-intercept of 2. And then I find out the slope. The first one is going to have a slope of 1, so 1 up and 1 right. And then the second one will have the slope of 4, so it's 4 over 1. So I go up 4, 1 right, and have the slope. Now when I graph these two equations, I am going to find out a point that both of these lines are going to meet. And that is going to be -3, -10. So that's going to be my solution of this system of linear equation. If you want to check if it's a correct point, what you can do is you can take those coordinate point, -3, -10, and plug it back into your original equations. And it must satisfy both of the equations in order to be the solution. So when I check both of these equations, they both will have -10 on both sides, so I know that I have graphed this correctly. Now, not all systems of equation will actually have one solution. Sometimes you're going to have other options, just like you had either horizontal or vertical graph to find out if it's function or not, or the slope. So first, I'm going to have us graph two different graphs for the first set, and then also take a look into the second set. The first set, we have the numbers for the equation 27x plus 9y equals 36. And the second one will have y equals 4 minus 3x. So what you're going to do is first you have to solve the first equation so that you can have y equals a number format. So when you do that, you are going to subtract 27x from both sides. So you have 9y equals -27x plus 36. And then I am going to divide all three items by 9. So be careful that you are dividing all three numbers. If you are only doing it for the y or only for 36, you're going to have the x with a different slope. So you go ahead and do that, and it's going to come out as y equals -3x plus 4. The second equation, you had 4 minus 3x, but if you change the order of the x and the number, you're actually going to end up with y equals -3x plus 4. So when you graph that, they're going to be an identical graph. So you're not going to have two graphs finding a single solution. When the lines are the same line, you're going to have infinitely many solutions because every single point of that line is going to be your solution. So that's the first one, first special system. If you have the same exact equation, same line, it's going to have all of the solutions the same. For the second part, let's say we have an equation 8 equals 4x plus 2y, and then the next one 2x plus y equals 5. In that case, we also have to change our equation into y equals something with a slope and intercept format. So I'm going to kick 4x to the other side so I can have y on the right side. And I'll have negative 4x plus 8 equals 2y. And the same thing happens for this one too. I'm going to divide everything on this item by 2 so I can have one single y by itself. So it's going to be negative 2x plus 4 equals y. And if you'd like to have the y on the left side for your convenience, you can change it and have y equals negative 2x plus 4. The second one, I have y on the left side, so I'm going to leave the y there and then move x to the other side. So I'll subtract 2x on both sides, so I have y equals negative 2x plus 5. Now once you graph this, you're going to first have 4 for the y-intercept, and the next one you have 5 as the intercept, and you'll notice that both of these lines are going to have the same slope. So let's graph it, and if you graph these, you're going to have parallel lines, two parallel lines that are going to never meet up at a certain point. So when lines are parallel, they do not intersect at any point forever, so there is no solution. The easiest way to know is to see their slope. If the slopes are the same number, you know that it's not going to meet up ever in their life. The next way that we can use is using a substitution. This is not going to be from the textbook, but I'm going to teach you this way because you will have to eventually learn this method for algebra class. So let's say we have a set of equation, y equals 2x plus 5, and another equation, x plus y equals 8. So what I'm going to do is first, I am going to substitute the variable that I know with something that is known to us. So for example, I don't know what x plus y equals 8 would have as a solution because you have infinitely many number of options that can make 8. But then I also have a condition for y, which is going to be 2x plus 5. So I'm going to take 2x plus 5 and substitute it in place of y. Then my equation is going to be x plus 2x plus 5 equals 8. Now I'm going to put the x's together because they have the same term or same variable. So I'm going to put 3x plus 5 equals 8. Now I can move my 5 into the other side. So I'm going to have 3x equals 8 minus 5, which is 3. And that means my x is going to be 1. Once I find out my 1, I can use one of these equations, either or, to find out what my y is going to be that would satisfy this equation. Because the second one is an easier equation, I'm going to just plug it into the second one. So 1 plus y equals 8. It's an easy one, so I can find out that my y is going to be 7 in this case. If you want to check this answer, you can go ahead and plug in 1, 7 for the first equation and see if that would make a true statement. So 7 equals 2 times 1 plus 5. In this case, 2 plus 5 is 7. So I know that it's going to be the solution for the first equation as well. So instead of graphing everything, I find out my solution, which is going to be 1, 7. And that's all you have to write down. If you have two equations that are both going to be in form like x plus y equals a number, you'll just have to change one of them into y equals or x equals a number form so that you can substitute it into the other equation. So I'll give you an example of those questions. Let's say I have 3y minus 2x equals 3, and also 6y equals 4x plus 6. You have two different ways to work on this, but I'm going to try to work on the easier way. if you notice that the second equation has 6y equals 4x plus 6, then I can change that into 3y equals 2x plus 3 if I divide everything by 2. So I'm going to change it to 3y equation so that I can plug it into the first equation where I have 3y minus 2x equals 3. So I'm going to go ahead and do that, and it's going to be 2x plus 3 minus 2x equals 3. Now if I do that, I am going to end up with the equation that will just have 3 equals 3. So I know that it's going to be an equation with infinitely many solutions because they are going to be the same number. So that's how I'm going to solve the equations when I have two different equations that are not written as y equals mx plus b format. Now for the homework for this lesson, I have specific instructions for you guys to follow. You'll have page 442, number 1, 2, and 3, so all of them, and all you have to do is to check if the given point is going to be the solution of those equations. Number 4 through 8, you're going to solve each system of equations by graphing. So you'll have to graph 4, 6, and 8 on a graphing paper or a graph that you create. And then for question 18, you'll just have to see if the ordered pair is the answer for the given solution. So that's something that you'll have to do. But for numbers 20 to 24, the 3 questions, I want you to use a substitution to solve the equation. So you don't have to graph them, just substitute one of these items so that you can have the answer by substitution. So that way you can practice this new way that we have learned.